We're going to go over more characteristics of functions, solely focusing on functions. We are going to look at extrema, which comes from the word extreme, and tomorrow is going to be the average rate of change. The first thing we're going to do is just kind of talk about where graphs are increasing, decreasing, or where they're constant, which is like horizontal line behavior. And then we're going to look at how we're going to determine where they're increasing and decreasing based on intervals. And then we are going to talk about relative and absolute extrema. And it's very easy. Remember, that just comes from the word extremes. Let's go ahead and clear out a few things first. I would highly suggest, if I write this down, you write this down. When it comes to the word intervals, please remember, because sometimes it's easy to get confused. Intervals is always about domain, and it is always interval notation. So remember, it's kind of easy to remember the word interval notation because it has the word interval. Here is one more big important point. Never brackets. So that's what you need to remember about this section. And of course, I'm going to talk about that more, but there's more stuff that I want to kind of make sure we have clear. When we talk about extremes, remember this is just ordered pairs. Just ordered pairs. That is all that is. Nothing more, nothing less. So still never brackets, of course, because it's ordered pairs. But please remind yourself it is just ordered pairs here. Ooh, barely got that to fit. Okay, so the reason why we bring this up is because both of these things are usually tested together, and they are usually, a lot of times in the same test or quiz question, so you don't want to get tripped up. Extrema is always ordered pairs. That's the big deal. Okay, let's go ahead and fill in these notes. Let me go back up to the top. Where it is increasing, if you notice, if I trace my finger along the graph like I read a sentence from left to right, my finger would go up this piece of paper. That's how I know it's increasing. Same over here. When you read it like a sentence from left to right, if I traced it, my finger would go down, and my finger would have no change in movement vertically on this constant line. So here's some very important things that you need to know. So remember, this is about the x values, because remember, guys, x values drive everything in math. They are always the drivers of the graph. And the next thing you need to remember is, as x is increasing here, y is increasing. So as x approaches infinity, the outputs, f of x, approach infinity, just as you go from left to right. This is known as same end behavior. And I'm going to abbreviate, guys. EB means end behavior. Now, for decreasing, what is happening as the x values decrease over here? Same thing. The y values are decreasing. So as x approaches still infinity over here, it is decreasing, but the x's are still approaching infinity. F of x is approaching negative infinity. So notice that is this called opposite in behavior. All right, one more thing that we're going to look at is constant behavior. And guys, all that is as x approaches infinity, f of x has no change. I mean, you can't really write this in algebraic terms, but we're just going to write no change here. Okay, so as we move along, I'm not using that color anymore, has no change. Now let's go ahead and look at these graphs here. So as we look at these graphs, we're just going to kind of trace from left to right. So as I trace from left to right, I would go down this page. So this is not increasing right here. This is decreasing. I'm going to put the x values right here. It decreases starting with a negative infinity, and it decreases all the way to a -1. Now guys, never ever ever include any values on when you're describing increasing and decreasing, because this end value is considered a turning point. Never ever ever include that value. No brackets in increasing and decreasing. So now if I take a look at this next piece right here, of course this is just a constant movement. Even though it has an open circle right there, I would still be using a parenthesis anyway. So it is constant along the x values from -1 to infinity. No change here, guys, so just write none. There's nothing that's going up. Okay, now let's take a look at the next one. So for the next one, we have some arrows here. As soon as I touch this arrow, my finger would climb up the page. So it is increasing from -infinity to that point right there, which is the origin. So I'm going to write 0, and I'm actually going to write kind of small because there's another piece where it's increasing right here that I have to fit. But I'm just going to continue to move from left to right. So after it hits the origin, it starts swirling down right here. So here's where it's actually decreasing. So it's decreasing where it left off at 0, and the graph continues to go down. It looks like that's at 3. Now remember, these intervals are always based on x values. There's no constant, but don't forget this is another turning point where the graph goes up again. So look, it is increasing here and from 3 to infinity. So remember, those are going to be the two places where they're increasing, here and here. None for constant. All right, now let's go ahead and look at the next graph. When I start reading the next graph from left to right, the first thing I see is an arrow. So it's going to increase from -infinity to that point right there, which appears to be -4. And then it stays constant from -4 to, what is that, up 2? I believe so. So let's write -4 to 2. Now, after it hits a +2, it goes down pretty quickly. So +2, this point right here, all the way down to that point. So from 2 to 4, it falls, it decreases. But look, here's another interval where it increases. So it increases over the interval of -infinity to -4, and it also increases from 4 to +infinity. Now I have to write kind of small there because I ran out of room. So that is how you describe increasing, decreasing, and constant behavior. Very important for you to remember that it is always x values, never, ever, ever use brackets.